So now we're going to do a binomial. We start with a binomial distribution, but we approximate it as a normal distribution because it meets the normal approximation condition, which is we'll write that condition here and then we'll talk about the context. So we have to show that NP and N1 minus P are both greater than equal to 10. And then we saw in the video that the shape of it will approximate a normal curve. But let's back up for a second. Let's make sure this is a binomial situation. So we're looking at a survey of 506 teenagers. So that is actually, instead of number of trials, that's actually N in this situation, is the number of teenagers we're picking. So that's N right there, 506. Where is the probability? And we're looking for the probability that they have a debit card. So what is that probability? Is it fixed? Is the probability of success fixed? And what is it? Yeah, it's 10%. Yes. So when you see a percentage, that can be P. It doesn't have to be a fraction, right? So that's P. So we know N is 506. Those are like trials. And we're asking if they have a debit card. We're assuming they're not lying. And so let's check to see if it's a binary situation. So what is the yes or no here? What's the B? They have a card or they don't. Or they don't. That's success or failure. So it's binary. Independent. So in this, it's a little weird to talk about independence, but it's basically just like one teenager having a debit card isn't going to change the probability another one does. So one teen's likelihood of having card doesn't affect the next one. And then number of trials is fixed at 506. So that's it. That's good. And then probability of success is P is equal to 0.10. Okay, so we're going to check if we can use the binomial approximation. So we do NP, which is 506 times 0.10. So we get 50.6. And N1 minus P is 506 times 0.9. It's basically number of successes and failures. And that is they're both greater than equal to 10. Therefore, we can use our formulas for the mean and standard deviation of a binomial distribution. And those are going to be given to you. Mu sub x is equal to NP. This first formula is pretty straightforward. Probably you would expect that the average number of students that have a debit card to be the number of trials times the likelihood of them having one. So just 10% of 506 or 50.6. That's the average we would expect. If we kept taking samples of teens, the average is 50.6. The standard deviation, sigma sub x, notice the symbols, is the square root of NP1 minus P. Now, that formula is derived in your book. I can go through it with you. You never need to know the derivation. You just need to know when to use it and how to. But I can always go through it with you if you like. So N is 506. The probability of success is 10, and of not success is 0.9. Those will always be complements of each other. And you get about 6.75. So we want to know the probability that we have 40 or fewer teens in this sample. What's the likelihood we get 40 or fewer? So we're looking for the probability the random variable x is less than equal to 40. And now we're pretending it's continuous because we're just approximating. And so we get to use normal CDF to do this. And we go from 0 to 40. That's the lower bound, the upper bound. We give it the mean that we just found and the standard deviation that we just found. But before we type this in on our calculator, because it's easy to make mistakes, do we expect a large likelihood because the mean is about 50 and The average distance away is about 7. So is there going to be a lot that are less than 40? If you're just approximate, there's not, because you know the empirical rule. And so there's not going to be many that are less than 1 standard deviation below. So if you, in fact, if you do that, you should get 0.0581. So there's only about a 6% chance that we're going to get less than 40 people with teenagers with a debit card.